Okay, so what we have learned last lesson is how to find the exact values for sine, cosine, and tangent, like to find all of those values. And we learned some formula which is called this symmetrical properties of circular functions. Like the table here is the formula. So for example, sine pi minus theta, that will give you sine theta. Cosine minus pi minus theta will give you negative cosine theta. I said, do not try to remember this table. What you can do is using this knowledge of finding the reference angle and then think about the quadrant to think about this formula as well. And today we're going to learn some more formulas, which is further symmetry properties and Pythagorean identities. This one is actually very, very important. Okay, so couple of new formulas we're going to learn. Well, there are 4 formulas we're going to 5. Okay, here it's all here. So the first two is sine pi over 2 minus theta will give you cosine theta. Okay, think about the difference between this page and this page. So what we have changed here, sine pi minus theta is still come to sine. Cosine still go to cosine. Tan still go to tangent. But here in this formula, sine will go to cos. Okay, when it's 90 degrees minus theta. What we have is on the previous page is pi minus theta, pi plus theta, and 2 pi is the multiple of pi. But in this case, we have pi on 2, which is 90 degrees. So if you want me to give you a not so proper proof, like I can prove somehow by using the right angle triangles. Think about in a right angle triangle. I have theta here. This angle must be pi on 2 minus theta. And that's 90 degrees. Okay, so 90 degrees, the two small angles add up, give you 90. Let's say that's A, that's B, and that's C. Okay, have a think about what is cosine theta. Cosine theta will be A on C. Okay, it's the adjacent over the hypotenuse. And let's think about what is sine pi minus 2, sine pi over 2 minus theta. Okay, opposite over hypotenuse is A on C as well. So those two values are actually the same. They all give you a ratio of A over C because they are the two different angles in right angle triangle. One is the opposite over hypotenuse and one is the adjacent over hypotenuse, which is the same length over the hypotenuse. So when it's 90 degrees minus theta, then the sine will turn to cos. It's the cos theta. And same reason for this cos. Okay, cos pi over 2 pi on 2 minus theta will be B over C. And the sine theta will be B over C as well. So they give you the same value. Okay, they give you the same value. But we can give this a little bit extension here. Not only acute angle can apply to this formula. All the angles, theta can be any value. I just give you an example showing in the first quadrant value why it is true for the first quadrant, but it is also true for the other quadrant. Okay, so this formula can apply to all these theta values, any theta value. So sine pi over 2 minus theta will be cosine theta. Cosine pi over 2 minus theta will be sine theta. You just need to remember those two equations, which is quite important. Okay, which is quite important. Let's have a look at the next two formula. We have here is 90 degrees minus theta. You can easily think about the angles in the right angle triangle. But when you have pi over 2 plus theta, that's a little bit different. Okay, that's a little bit different. But don't worry, let's have a think about where is, okay, what I want to do is I want to think about sine pi over 2 plus theta. Okay, where is this angle? If theta is an acute angle, which quadrant this pi over 2 plus theta will be? Which quadrant? Second. Is 90 degrees go a bit like over? So let's sketch this angle here. Okay, I would say that's this angle here. Well, I don't know how large is theta, but like this angle will be pi over 2 plus theta. What do you think is the reference angle? Can you give me an expression for the reference angle here? Well, it will be this angle here, right? What's the size of this angle? Yeah, pi minus this angle, right? So it's pi minus bracket pi over 2 plus theta. So what that equals to? That's pi over 2 minus theta. Okay, that's the reference angle. So I can change this into the reference angle because any angle can convert into the reference angle. This is the reference angle. And also I need to think about the quadrant. This is the sine quadrant. Sine will get positive value. Okay, sine is positive. I'll have positive that after I change it to the reference angle. I change it to the reference, I check the quadrant, is the sine quadrant is still positive. And again, this question go back to what we have learned before. What is sine pi over 2 minus theta? We just learned that. What is sine pi over 2 minus cos theta? Okay, we just learned that on the previous line. So that's cosine theta. So that's why cosine pi over 2 plus theta, that still equals to cosine theta. Okay, sine pi over 2 plus theta, that is still cosine theta. You don't really need to know the proof. What you can do is just remember it, or like if you feel like I feel it's easier for me to go through the proof step. Okay, so I will go through the proof step. If you don't think like the proof is necessary, you can just remember the formula and apply for it. Okay, I have cosine pi over 2 plus theta as well. Okay, it is the same angle. It is in the second quadrant. And I want to change this into the reference angle, which is pi over 2 minus theta. I change the actual angle to the reference angle, and I'll think about the quadrant. This is the sine quadrant. So cosine will get negative value. So I change that into negative. And also I know cosine pi over 2 minus theta, that is sine theta. That is actually sine theta. So this equals to negative sine theta. So cosine pi over 2 plus theta is negative sine theta. That's how we do those two formulas. Okay, that's the 4 equations here. Like that's the 4 formula we'll use here. So the difference between this one and the previous exercises, the previous exercises all relate to pi or 2 pi or 0, like something like that. Pi plus theta, pi minus theta, 2 pi minus theta, minus theta. That's what we learned in the previous exercise. But in this exercise, it's all combined with pi over 2, which is combined for 90 degrees. Okay, so that's those 4 formulas. What you need to do, just remember them, find a way to remember them. There's these 2 are quite important. Well, we seldomly really use those 2, but you still need to know for that. And the most important one is this one, the Pythagorean identity. Okay, what is the Pythagorean identity? Which is Pythagoras, a squared plus b squared equals to c squared. This is the most important one because we use that a lot. Okay, what we're going to have is, I'll just draw a unit circle, okay? So I have a unit circle here. And I have any angle of this. Okay, this is theta. This length is x. X represents the cosine. So this is cosine theta. And this is the y. Y represents the sine theta. Okay, y is cosine theta, y is the sine theta. And what's this length? This black length here. The hypotenuse of this triangle. What's this black length? 1. It's a unit circle. Only in unit circle we talk about sine, cosine values. And the radius just 1. It is a unit circle. So what we're going to have is sine squared plus cosine squared equals to 1 squared. Because Pythagoras, okay, a squared plus b squared equals to c squared. So we have cosine squared theta plus sine squared theta equals to 1 squared. Okay, this square here, okay, when we write the power for sine, cosine, or tangent, okay, for example, that's cosine squared. That's what we're going to have. Okay, cosine squared plus sine squared. But like make it look better, we just write the square in the middle of theta and cosine. It's just a notation thing. When you see the square in the middle, it means the cosine theta whole thing squared. Not the cosine squared. It's the cosine theta whole thing squared. It's just like for notation. It looks better. Okay, it looks better. So that's why we write the power in the middle of the cosine and theta, in the middle of cosine and the angle. So when you write power, so cosine, for example, a half theta, which means that equals to square root of cosine theta. Okay, so it's cosine theta to the power of a half. So that's square root cosine theta. We write all the power in the middle of the cosine and the angle. So that's how we write the power. Okay, why I said this Pythagorean identity is very important? Because think about, if this is an equation, if you know the sine value, you will know the cosine value, right? If you know the cosine value, you know the sine value. So if you know the sine value and the cosine value, then you will know the tangent value, which means by giving you this formula, knowing any value for cosine or sine, I can know all the other two trigonometry ratios, okay, cosine and tangent. So if given you sine, I can find cos by using this formula, and I can find tangent by using sine divided by cos. So this formula can allow us to find all the values. Okay, let's have a look at example here. For this example, if cosine theta equals to minus 0.4, okay, let's write that into the fraction form. So cosine theta equals to minus 2 on 5. 0.4 is 2 on 5. So cosine theta is minus 2 on 5. Okay, I want to ask you first. Your theta is in between this range. Which quadrant is that one? Which quadrant your theta is in? The third one. Pi to 3 power over 2 is in the third quadrant. In the third quadrant, your sine value will be positive or negative? Negative. And your cos value will be negative as well. That's why you have a negative 0.4 here. Okay. Now is giving you the cosine value and ask you for the sine value, we must use the Pythagorean identity to find out that. So the formula we have is sine squared theta plus cosine squared theta equals to 1. Therefore, sine squared theta plus minus 2 on 5 squared equals to 1. Then sine squared theta equals to 1 minus 4 on 25. Okay, 1 minus 4 on 25, which give you 21 on 25. 4 on 25, 1 minus 4 on 25 is 21 on 25. Okay, here is the very, very important step. What sine theta equivalent to? What sine theta equals to? Everyone think this question is just a like is that x squared equals to 21 or 25? What x equals to? It is square root. But anything important in the front? Plus minus. When you take square root of something, you need to have the plus minus value. X squared equals to 4. X can be positive 2 and negative 2. Okay, that gives you that. So this equals to plus minus, well, square root of that is square root 21 over 5. Everyone remember, you must write this step. You must have this plus minus. Even though I just said the minus is not working, the plus is not working because sine theta should be negative. Okay, should be negative. Even though the positive is not going to be your answer, you still need to write that out in this step. Because in math, this one can be square root 21 over 5 or negative square root 21 over 5. But in the application point of view, the next step what we're going to talk about is because theta is in between this range, so sine theta must be less than 0, is a negative value. Therefore, sine theta, well, I'll write like in blue color. So sine theta equals to negative square root 21 over 5. Okay, so you must write both solutions. Okay, how do we get both solutions? We get that from the equation. In your equation, what you can solve out, you need to write all the possible values out. And then you have the discussion, whether it's out of domain or whether the range doesn't fit, like then you reject one value, you choose one value. That's similar to the question you have on your exponential test. When you're trying to solve for the log equations, you have create a quadratic. And in that quadratic, you need to have two values. Okay, one is negative 2, I think, and the other one is 4 or something, or 3, I can't remember. You can solve out two values by this quadratic. Some of you just directly reject one because you know like the negative one not going to work. That's not correct. Okay, you must list out all the possible value. For that equation, you write. Okay, for the previous line, you write what is the equation. You need to write both of them. And then you can't just reject one by not telling anything. You need to reject it by some reason. You need to write the reason down. So you need to say, okay, because of the domain doesn't fit when x equals to negative 2, then we reject that one. So x is blah, blah, blah. Okay, you can't directly reject the value. You need to give a reason why you reject it. And you need to list out both answers and then reject. Same as here. When you know sine or when you know cos, you want to know sine or cosine, you always can solve out two values for sine and cosine because you always have plus minus by using this formula. It's square and square. Therefore, you need to talk about the theta is in between which and which. And then, therefore, that will give you a positive or negative value for that sine or cosine you're trying to figure out. And then you choose a value, so it's negative or positive. Okay, that's the full step. You have 2 marks. 1 mark is given here, and the other mark is given here. Okay, that's your 2 mark. 1 mark is for both values, and the other one is giving a rejection value. Okay, so that's how do we find a sine value by using the cosine. And the next thing we're trying to work out is the tangent. Because you already know the sine and cosine is basically sine divided by the cosine. And that is negative root 21 on 5 divided by negative 2 on 5. And this will give you root 21 over 2. Root 21 over 2. Okay, theta is in the third quadrant, so tangent must be positive. And we, by using this formula, find out a positive value, which means we're doing something correct. Okay, like not say definitely correct, but like it makes sense. It makes sense. Well, if you solve out your cosine value is positive in this case, then you will have a negative tangent, and you know you're doing something wrong because your tangent should be positive. Okay, you can check by looking at the positive or negative. Okay, next one. Sine pi over 2 minus theta. Okay, not looking at the formula, what that will equals to? Cos theta. Okay, 90 minus theta will change into the other Sine will change to cosine, cosine will into sine. So cosine theta is negative 0.4 or negative 2/5. So you can directly use this. Okay, cosine pi over 2 minus theta, what that equals to? Sine theta. So sine theta is negative root 21 over 2. Negative root 21 over 2. That's what we figured out in A.
5.
Oh, 5, sorry, that's a tangent. Yeah, 5, thank you. Okay, sine pi over 2 plus theta. Sine pi over 2 plus theta. What that equals to? Cos theta, positive cos theta. Sine will go to positive cos. So that's positive cos theta. But cos theta is already negative 0.4. So I'll have negative 2/5. And the last one we have is cosine pi over 2 plus theta. That will turn into a negative sine theta. A negative sine theta is root 21 on 5. Because sine theta is negative, and you have negative again, it's a positive root 21 on 5. Alright, that's this exercise. In this exercise, it's like we learn 5 formulas. The Pythagorean identity is very, very, very important. And the other 4 formula, you just need to know about it, whether you can remember it or you can try to approve for it. Okay, that's this exercise. And let's go to the next page, which is sketching sine and cosine graph. Okay, sketching sine and cosine graph. Okay, so everyone just needs to pens down now and listen to me to tell you the story of the sine and cosine graph. What you need to know is I may show you a different method of what you have learned, whether like before or like tuition centers. Like I may give another way of doing this. I'm not going to do this exercise by exercise. I'll go to do 3 exercises all together. Okay, I'll do it at once all together. So I just want you to know the basic rule about sine and cosine graph. I think everyone know a little bit about it because year 10 we teach that actually. So this one is a sine x graph, a really normal sine x graph, and the bottom one is a really normal cosine x graph. It's like a wave, it's keep going up and down. With the same distance, they are actually symmetrical and identical, okay? Same period, same curve. Okay, before we going through that, we have a look at the general equation for sine graph or cosine graph. I can change that to a sine or a cosine. That works for both sine and cosine. So tangent is another story. So let's have a look at sine and cosine first. So for sine graph and cosine graph, as we learn hyperbola, truncus, or exponential logarithm, I always give you the general equation first. Okay, what can be changed? So in this case, what can be changed is the value times in front. There's the a value here. Okay, what I will write, like I will give a 2 here. So sine. Okay, I can put a square bracket around that. It's all the angle. It all belongs to the angle. Okay, sine. N value. N is the coefficient for the x. So I can make a half bracket x plus, okay, epsilon, this is called epsilon, I can say that's pi on 3. And then plus or minus b, I will say minus 4 here, in this case. Okay, I'll give you a general equation like that. That's a most complex equation you can have. So what all of these numbers represent? This a value represents amplitude. It will affect the mean or maximum or minimum. Okay, so what is amplitude? Let's not think about that first. Let's think about the last number first. Minus 4. What is this minus 4? This is your middle level. That is the, well, you know your sine graph and cosine graph will have extreme point. So maximum or minimum. So in between your maximum and minimum, this is called the midline, which is the middle, where your points stay like in between the max and minimum. That is the middle. So the middle is -4 in this case. What we're going to do if we're trying to sketch this graph, we will just draw this like the Cartesian plane, and I will find where is -4. -4 is here. I will just give a dash line, and I know this is the middle of my graph. This is the middle of my graph, -4. And then let's come back to the amplitude. So what is the amplitude? Absolute A is the amplitude, because sometimes you can have a -2. You can have a -2. So it must be the absolute value is the amplitude, which is 2. What amplitude means? Amplitude means how much the graph can go up from the mean and how much the graph can go down from the mean. So mean is -4. How much it can go up is 2 units. Okay, it can go up by 2 units. So the maximum value for this graph is -2. Okay, the maximum value for this graph is -2.
If the year 10, start making your way to the years now. Thank you.
Okay, y equals to -2. Go up by 2 units. And how much it can go down? It can go down by 2 units, which is here. This y equals to -6. So y equals to -4 is your mean line. It's called MEAN, the mean line. And y equals to -2 is called the maximum line. It's the go up by 2 units, is the max. And then -2, which gives you -6, that's your minimum line. Okay, your graph will move in between those 3 lines. For example, a possible move will be this. Okay, it will move in between those 3 lines. You can't go over than that. Okay, so I have explained the value A and value B, what those 2 values represents. That's one of that is the mean, one is the maximum, one is the minimum, and that will give you 3 lines on your graph first. Okay, the next thing we're talking about is this n value here. This value, half. This value half. What this value will do? This is the coefficient for your x. Okay, coefficient of your x. So this value actually affects your period. Do you know what's the normal period for sine and cosine? 2 pi. Okay, so it experiences 2 pi. So to complete 1 cycle, that will be 2 pi for both sine and cosine. So the new period will be 2 pi over this n absolute. Okay, n absolute. Absolute means the positive of that. If n is -half, I will still take half. So the period for this graph equals to 2 pi divided by a half, which is 4 pi. It will take 4 pi to complete 1 cycle. Okay, it will take 4 pi to complete 1 cycle. Okay, that's n value. And what's this epsilon, the bracket, the pi over 3 means? That means horizontal movement. It's either move to the left or move to the right. In this case, the whole graph will move to the left. But I don't care about this value, okay? I don't really even look at this value. So to sketch my graph, I don't really think about the movement. I will find points. I will show you how to do it. But like, what I'm interested in is first the midline. That's the first thing I look at, the middle. Where's my middle? The next thing I'll look at is how much I can go up and how much I can go down. It's the maximum and minimum. That gives you the maximum and minimum. 3 lines labeled first. And the next thing I will work out is the period, which is affected by the n value. Okay, it's 2 pi divided by the n value. That will give you the period. That's how you calculate the period. Okay, that's the first thing I will do. And number 5, I will show you after I finish this. Okay, that's the first 4 thing you will do when you sketch a graph. Okay, now let's have a look. The midline will be y plus or minus b. That's the last value you add up. And the minimum will be the mean subtract the amplitude. The mean subtract the amplitude. And the maximum will be the mean add the amplitude. Okay, the mean add the amplitude. So quickly go to look at this example. Well, that's all explanations. This example here. For example, in this case, example 1, the mean value will be 2. The mean value will be 2. The maximum value will be 5, which is 2 go up by 3. Okay, go up by 3. The amplitude is 3. And the minimum will be 2 subtract 3 and give you -1. So the 3 line will be 2, 5, and -1. The middle is the 2, the max is 5, and the minimum is -1. And what's the period in this case? What's the period equals to? 2 pi over, have a look at your equation. That's the coefficient before the t value. Okay, this is the coefficient, the absolute value of the coefficient, which is the 2. So it's 2 pi over 2 will give you a period pi. So in the length of pi, you can have a complete cycle of the graph. Okay, let's go back to the front. That's just an introduction for what is the A, B, and N value represent. Okay, that's the most exciting part here. You may can't see from your graph, but you can see from my graph. Okay, have a look at this graph. This graph is 1 period. I take 1 period from the sine graph. It's in between 0 and 2 pi. It actually experienced 4 stages. The first stage is an increasing stage. It from the mean, the middle, go to the maximum. And then from the maximum, go back to the mean. And the mean will decrease into the minimum, and then the minimum go to the mean. Okay, if ask you to predict the next movement, where the point will be for the next stage? Well, mean, max, mean, minimum, mean. What's the next point will be? Max. And then the next? Mean. And the minimum. You keep going for this pattern. Okay. So that's the y value, okay, the point for the y value from the mean to the max, to the mean, to the minimum, to the mean, to the max. Okay, think about that horizontal movement. For each time of the movement, how long the x experience, like how long the x moves. Okay, so for example, for the mean to the max, how long is this x? How far from the horizontal distance it moves? Pi over 2. Okay, then from the max to the mean, how long it experienced? Pi on 2. How about mean to the minimum? Pi on 2 again. And then last here to here is pi on 2. So in each period, it will experience 4 stages. Each stage will take a horizontal distance of pi over 2. But it's not always pi over 2. You cut your period into 4 steps. Each step, your point will move from mean to the max, max to the mean to the minimum, minimum to the mean. So it's actually all symmetrical. And I cut each period into 4 stages. So this is called a step length. This step length equals to the period divided by 4. Equals to the period divided by 4. Each case, your period will be cut into 4 stages. And then from each stage, it will move either from the mean to the max, or max to the mean, or mean to the minimum, or minimum to the mean. Like it's keep going in that pattern. So there is a pattern for the graph. Okay, there is a pattern for the graph. Same as the cosine. See the cosine start from the max, then go to the mean, the minimum, mean to the minimum, minimum to the mean, and mean to the max. Just keep going with this pattern as well. And for each point of movement, the horizontal distance is 1 step length. Each step, it will take the period over 4 of the length. Okay? So that's what I'm going to talk about. Now have a think about one thing. If you currently know this is the maximum point, after it experiences the one step length, this point will definitely move to the mean line, right? And then after another step length, that point definitely moves to a minimum, and then minimum to a mean. So you actually know the pattern. Or say if you're currently at a minimum point, you know after one step length, the minimum will go to the mean line, and then the mean will go to the max. So it still follow a particular pattern. But have a think, if you're currently at a mean on the mean line, can you predict which is the next movement? Can you really predict it? It can either go up or go down. Like, I don't know. There will be a particular movement by knowing the equation, but by just look at the point, I won't know the next movement. So the important thing for me to sketch the graph is to find either a maximum point or a minimum point on this graph first. Okay, to find a maximum or a minimum point on the graph first, because this can allow me to know the movement of the next step. Because by knowing the equation, I can find my period. I can know each step length, how long is each step length, and I will know the movement of all this point if I know either a maximum point or a minimum point. So if I know a mean line point, it doesn't help. If it's a mean line point, it doesn't help because I don't know whether it's go up or go down. So by saying that, this is the step of sketching this graph, okay, of sketching the sine graph. So only for sine, okay, this is only sketching for sine. When you sketch cosine, there will be a little change, okay, a little bit change. Only one step change. So for the first step, as I have talked about, I need to label the mean line, the maximum, and the minimum. So I need to label those 3 lines. Okay, step number 5 is find the period. I know how to find the period. Number 5 is find each scale length, or say the step length. Each step length will be period over 4. You know from max to mean you take period over 4 of the step. So each step you will take period over 4. Not pi, is period over 4. And number 7 is follow the pattern. This is like we leave to the end. So stage number 4 is the most important stage. Is to find the start point. Okay, what is the start point? The start point must be at a maximum point or a minimum point. That is a start point. Okay, how do we find it? How do we find it? We will make the whole thing in the sine, the angle, okay, basically the angle put into the sine. Make that equals to pi over 2. I will make the whole thing equals to pi over 2 here. I want to know what t-value can make the angle become pi over 2. That's my starting point. Why I want to have pi over 2? Well, it can be any other value. It can be some other values, but I'm not going to show you other values. Sine pi over 2 will be the most convenient one. Why is pi over 2? Because have a think. Sine pi over 2. What sine pi over 2 gives you? No, 90 degrees. Sine 90 equals to what? 1. 1 is the maximum value for sine can take. Does that make sense? 1 is the maximum value sine can take. Sine is in between -1 to 1. 1 is the extreme value already. All the other value will be 0.5, 0.6, -0.2, -0.3, -211, all of those values. Only maximum value will occur on pi over 2. That's the extreme point. That's the highest value, which is pi on 2. So I make the whole angle into sine equivalent to pi on 2. I want to have an investigate on what t-value can give me the extreme point. So that is, we solve for t. After we set up the equation, we solve for t. I can solve out some t-value. And then you may ask me, is that a maximum point or a minimum point? I will say, look at the a value for the next step. Look at the a value. If the a value is greater than 0, then that will be a maximum point. If the a value is less than 0, c will give you a minimum point. Okay, you solve out that. So t equals to c is when you solve out that equation, what you get? You get t equals to c. That c will give you a maximum if a is positive. That will give you a minimum if that a is negative. Well, that's the only complex step you need to do for sketching the graph. After you do this step, everything becomes so easy. So you just need to remember one thing. To solve sine graph, you make the whole thing in the bracket equals to pi on 2. Second, solve for that t value. Third, to test whether that t value give you a max or a minimum by looking at the a value. If a is negative, that's a minimum. If a is positive, you will get a maximum. Then you have confirmed a starting point. Okay, let's just do this example below here. Okay, I'll show you this. After I show you, it will make much sense. As we already work out the minimum, maximum, and midline, I will just using a red color to label that on my graph. My midline is 2. Well, you don't really need to label it. It's just like for me, easy to sketch. Well, I need to take it off later, so you may use a pencil to sketch this. So equals to 2 is here, and equals to 5 is here, and equals to -1 is here. So my graph must be in between those 3 lines. Okay, my graph must be in between those 3 lines. And I must have my step length. My period is pi. My step length equals to pi over 4. For each step the point want to move, you will take pi over 4 to move. Okay, to move to next stage. Okay, now I need to solve for a starting point. Okay, the whole angle combined with sine is this angle here. Is 2 bracket t minus pi over 4. That's my complete angle in the sine. I want to make the whole angle equals to pi over 2 because that's when the t will give you a maximum value or minimum value. So I'll solve for t. T is t minus pi on 4 over pi on 4. Yep. If it's a sine graph, it's always pi on 2. Cosine will be different, but if it's sine, it's always pi on 2. So t equals to pi over 2 here. That's my starting point. Do you have a positive a value, a minimum a value, a positive or negative a value? Positive, which is 3. So a equals to 3, which is positive. So I will have a maximum point. So pi over 2 will get a maximum. Maximum is 5. So I will have this coordinates. That's my first point. That's my first point. So my first point is here. I will label my first point. That is my first point. Pi over 2 and go to the max. That's my first point. Okay, next step, we'll take pi on 4 to happen. Take this much to happen. Pi on 2 is here, take pi on 4, which is here. I will come to here. Then this point will go to the midline already because it takes a step length of pi on 4. Okay, this much is pi on 4. Therefore, your point will move to the next stage, which is the midline. And I'll take the next step, which come to pi. But I will reach the minimum. That's my minimum. And I will take another step to reach 5 pi on 4. That have mean as well. Okay, minimum will go to mean. And I think it's my domain. Okay, my domain is pi on 4 over to 5 pi on 4. That is my stop point. Okay, I need to stop there. And don't forget, I can also go left as well. Okay, I can also go left because pi on 2 is not my stop endpoints. So I can go left by pi on 4 units, which I reach pi on 4 here. That will go to the mean line as well. Because it's max before, it must be mean for the next. So I have mean on this side as well. So that's the point I have in between my period. In between my period. If I can complete the graph is follow a sine shape or cosine shape. The graph must look like this. you know how to complete the graph, okay? Like a sine graph, that's like a curve. So after all the points has been labeled, you definitely can connect them and give the correct shape. So if I label the point, that's pi over 2, the maximum will be pi over 2 and 5, and the next one will be 3 pi over 4, 2, and the minimum is pi negative 1, the endpoint is 5 pi over 4 and 2. That's my complete shape of this graph. And I can take off the 3 line, that is the graph. That is the graph. If I can find a start point, if I know how long it will take for each step, then I can label all the rest key points on this graph. And I can use the pattern to complete the chain of the graph. So that's how do we sketch sine graph. Okay, how do we sketch sine? I haven't taught you how to sketch cosine yet. Okay, let's just focus on sine. I'll go through cosine next lesson. Cosine will be an easy change, a really easy change. Okay, so we'll stop here today. You can go to practice some sine graph at home, which is exercise J. Okay, go to sketch exercise J for sine graphs. Okay, complete homework for 14J for sine graph. Okay, for sine graph. Any sine graph you can see, you can practice on that.